Imagine you're standing on the deck of a research ship somewhere in the middle of the Pacific, halfway between Japan and Papua New Guinea. Beneath you was nothing but blue water, calm and ordinary looking. But beneath that water is a wound in the planet almost 11,000 meters deep, deeper than Mount Everest is tall. You drop something small over the side, a steel ball, a pebble, maybe just a coin. It vanishes in under a second. And then the real journey begins, one that most people get completely wrong. Most people imagine the object just falls, faster and faster, like a stone dropped off a building. They picture it crashing into the bottom in a few minutes, or imagine the pressure instantly crushing it the moment it touches water. Neither of those things is true. What actually happens is slower, stranger, and far more violent than a simple fall. Let's follow it all the way down. For the first 100 meters, almost nothing changes. Sunlight still penetrates, the water is still warm, and your object behaves the way physics class taught you it should. But somewhere around 200 meters, the light starts dying. Not gradually like a sunset, it disappears in stages, color by color. Red vanishes first, then orange, then yellow. By 1,000 meters, your object has entered a zone scientists call the midnight zone, where no sunlight has ever reached, not once in the entire history of the planet. From here to the bottom, the only light that will ever exist is the light produced by the creatures living in it. To understand what happens next, we need to talk about something most people never think about: how fast something actually falls through deep water. In the movies, anything dropped into the ocean sinks in seconds. In reality, water is roughly 800 times denser than air, and that density fights every object the entire way down. A small, dense object like a steel ball or a heavy pebble settles into what's called terminal velocity. That's the speed at which gravity and water resistance cancel out, so it stops accelerating and falls at a steady pace. For something small and dense, that pace works out to roughly 1 meter per second. Do the math on an 11,000 meter trench, and you get something most people never expect. It doesn't take minutes, it takes hours. A small object dropped to the surface won't reach the bottom of the Mariana Trench for nearly 3 hours, and that's if it falls in a straight line, which it almost never does. Ocean currents don't stop just because there's no sunlight left. Deep below the surface, slow-moving currents called thermohaline currents drift through the water column, driven by tiny differences in temperature and salt content. They're nearly invisible and nearly silent, but over 3 hours of falling, even a current can drag an object sideways by hundreds of meters. Drop something directly above the deepest point of the trench, the spot called Challenger Deep, and there's a real chance it lands somewhere else entirely. So your object is falling, drifting, and now entering a zone where the water itself starts working against it in a different way. To understand why, we need to talk about pressure and just how extreme it actually becomes. At the surface, you're under 1 atmosphere of pressure, a number so familiar your body never even registers it. For every 10 meters you descend, you add roughly 1 more atmosphere. By 1,000 meters, you're under 100 atmospheres. By 5,000, 500. And at the bottom of the Mariana Trench, the pressure climbs to over 1,000 atmospheres, more than 16,000 pounds pressing on every single square inch. To put that in terms that make sense, it's the equivalent of stacking roughly 50 jumbo jets on top of a single point the size of your nail finger. It's pressure strong enough that a styrofoam cup sent to the bottom doesn't crack or shatter. It shrinks perfectly, like a tiny crushed replica of itself, the air forced out of every microscopic bubble in the material. This is where most assumptions about dropping something into the trench start to fall apart. People assume solid objects get crushed instantly, like a soda can underfoot. But solid, dense materials like steel or stone don't behave that way. Water itself is nearly incompressible, and so is solid metal. Crushing happens to things that contain trapped air or gas, hollow spaces, sealed containers, lungs. A solid steel ball doesn't implode at the bottom of the trench, it just keeps sinking, completely unfazed by pressure that would kill a human in a fraction of a second. But humans did try to go down there, and what happened to them tells you everything about how dangerous this environment really is. In January 1960, two men climbed into a steel sphere barely over 2 meters wide, attached to a massive float filled with nearly 129,000 liters of gasoline. Not for fuel, but because gasoline is lighter than seawater and barely compresses, making it the only practical way to keep a vessel buoyant at extreme depth. The vessel was called the Trieste. The men were Jacques Piccard and Don Walsh, and their goal was to do something no human had ever done: reach the very bottom of Challenger Deep. The descent took nearly 5 hours. Then, in around 9,000 meters, with 2 more kilometers still to go, the entire vessel shuddered. A loud crack echoed through the steel sphere. Outside, one of the thick plexiglass viewing windows had fractured under the pressure. They had a choice: abort the dive or continue into the deepest, most crushing environment on Earth with a damaged window. They chose to continue, reasoning that if the crack had been catastrophic, they would have already dead. They reached the bottom. They stayed for 20 minutes, and they saw something nobody expected to find in a place considered too hostile for life to exist at all. This is the part of the story that turns the whole trip on its head. Before this dive, the leading scientific assumption was that nothing could survive down there. No light, freezing temperatures barely above 0 degrees Celsius, and pressure that should crush biological tissue into nothing. But through that cracked window, the two men reported seeing movement. A flatfish gliding across the silty bottom, completely unbothered by conditions that had just nearly destroyed a steel and gasoline vessel built specifically to survive them. Turns out the trench isn't empty. It's home to organisms that have spent millions of years adapting to exactly these conditions: bodies without internal air pockets to crush, cellular structures reinforced against pressure that would liquefy ordinary tissue. Life didn't avoid the deepest place on the planet. It simply found a way to thrive there, while everything built by humans had to be engineered around the threat of total structural failure. So, back to your object, the steel ball, the pebble, the coin, now finally approaching the bottom after nearly 3 hours of falling through total darkness. What does it land on? Not rock in most places. The floor of the Mariana Trench is covered with a fine, pale sediment, a slow accumulation of dead microorganisms and mineral dust that has been drifting down for millions of years. Your object doesn't crash, it settles gently into a surface as soft as flour, kicking up a small, slow-motion cloud that takes minutes to resettle in water this dense and this still. And then it simply stays there. No currents strong enough to move it again, no sunlight to degrade it, no oxygen-breathing organisms in large numbers to break it down quickly. Depending on the material, an object dropped into the Mariana Trench today could remain essentially unchanged for centuries, a strange, accidental time capsule resting in the most inaccessible place on the surface of the Earth. Here's the part almost nobody considers. Humans have already been doing this for decades, and not on purpose. In 2012, filmmaker James Cameron piloted a submersible called the Deep Sea Challenger to the bottom of the trench solo. But long before that, and long after, scientific equipment, lost tools, fishing debris, and even plastic waste have been making the same 3-hour journey down, settling on that soft sediment alongside organisms that have never encountered anything like it. In 2019, explorers reaching the bottom of the trench reported finding what appeared to be plastic waste already resting on the seafloor, meaning humanity's deepest accidental footprint may already exist in the one place on Earth almost nobody will ever see again. So, what really happens if you drop something into the Mariana Trench? It doesn't get instantly crushed, it doesn't fall in minutes, it drifts sideways on invisible currents, falls for nearly 3 hours through total darkness, survives pressure that would atomize a human body, and lands gently in fine silt next to life that evolved specifically to exist in a place we once assumed was impossible to survive. The deepest point on our planet isn't a void, it's just a place we've barely begun to understand, closer to us than space, and yet far less explored. If stories like this make you think differently about the planet beneath your feet, stick around. There's a lot more down there we haven't covered yet. And let me know in the comments,
If you could drop one object into the Mariana Trench just to see what happened to it, what would you choose?